Okay, so I'm going to work through a couple of these trig identity problems just to kind of give you an idea of how to work with them. We're going to start with these two and just kind of go step by step through how I would do it. Again, this is not the only way to do it, just something that works, okay? So let's start with number 4 here. It's cosine x plus sine x tangent x equals secant x. Now remember, we want to pick the more complicated side and try to simplify that. So I'm going to work on the left and try to simplify it down to be equal to secant x. I am going to start by rewriting tangent as sine over cosine. So there's my first identity that I'm substituting in. Now I am going to combine sine x times sine over cosine, which is sine squared over cosine. And I'm going to get a common denominator, which is going to be cosine x, which means I'm going to multiply here by cosine over cosine, which is going to give me cosine squared plus sine squared over cosine x. Now remember, my goal is to end up with secant, and I'm kind of keeping in the back of my head that I know secant is equal to 1 over cosine. So if I can somehow get 1 over cosine, then I know I'm one more step till the end. Now looking at this, I know I have an identity that cosine squared plus sine squared equals 1. So I'm going to simplify that. And I got 1 over cosine x, which is exactly what I was talking about. And I know that 1 over cosine is equal to secant. So I can finally make the statement that secant x is equal to secant x. We have proven what we wanted to, and we are done. Let's look at also number 7 here. I want to, let's see, I'm going to use this. Work through this one. Again, I want to work on the left-hand side to try to simplify it so that it looks like the right-hand side, okay? So I'm going to start, let's see, what might be a good thing to do. Let's rewrite cotangent as cosine over sine. I don't really have a super fantastic reason for that other than I need to try something. These problems, it's so important to just start. Just try something, see where it gets you, and go from there. So now I'm going to combine on the top, and I'm going to get cosine squared theta over sine theta divided by 1 minus sine theta minus 1. Okay. Now let's see, what else can I do here? Why don't I just get a common denominator with this 1 and put it all together? So the common denominator would be 1 minus sine theta, and negative 1 times that is minus 1 plus sine theta. Okay, so now I've gotten rid of that minus 1 hanging off the end there, and I've simplified a little bit. By the way, what I did was I multiplied here by 1 minus sine theta over 1 minus sine theta. Okay, I multiplied the 1 by that, which gives me a common denominator that I can put together. Now, just remember that you're subtracting. So when I subtract 1 minus sine theta, it actually becomes negative 1 plus sine theta. Okay. Let's see. From here, what else do we want to do? Well, excuse me. Let's get a common denominator on the top, maybe. And make this a sine theta. So I'm going to multiply the negative 1 times a sine theta, and I get negative sine theta plus sine squared all over sine all over 1 minus sine. It's a little complicated here, but we're working through. That's what we need to do. Now, I know that cosine squared plus sine squared is equal to 1, so I'm going to rewrite this on top as 1 minus sine theta over sine theta over 1 minus sine theta. Now, remember, in reality, I have this over 1 in the denominator, right? Now, the reason I point that out is because anytime I'm dividing by a fraction, I can flip and multiply. So what I'm going to do is I'm going to flip this and multiply it to the top. Let me rewrite this so you can see what that looks like. The reason I do this is because when I'm multiplying, I can cancel out the 1 minus sine theta, and I'm left with 1 over sine theta, which from our reciprocal identities we know is just cosecant theta. And I'm going to flip up because it's been a while. That is what I was trying to prove. So I can write my final statement of cosecant theta is equal to cosecant theta, and I am done. Hopefully this helps you out a little bit in understanding what you're doing with some of these trig identities. Again, feel free to pause and try something and see where you go, or use this to kind of give you some helpful hints. Best of luck.